short video, we're going to revisit examples 2 and 3. Now, sometimes we can solve for the variables introduced in partial fraction decomposition by substituting strategic values for x, as illustrated in exploration 1. Now, when we cleared fractions in example 2, we obtained the equation 5x minus 1 is equal to a sub 1 x minus 5 plus a sub 2 times x plus 3. In our example, though, I used a and b, so I used a for a1 and b for a2. Get you the same exact result. Now, when I put x equals 5 and solve for a2, this is what you'll get. 5 times 5 minus 1 is equal to a sub 1 times 5 minus 5 plus a sub 2 times 5 plus 3. Doing a little simple mathematics here, we'll see that the left side will be 24. This will go to 0, so we don't need it, and this will be 8 times a2. That means a2 will equal 3. Now we're going to do the same thing, except we're going to substitute negative 3 in for x. So 5 times negative 3 minus 1 is equal to a1 times negative 3 minus 5 plus a2 times negative 3 plus 3. So we'll have, doing some simple simplification here, negative 15 minus 1 is negative 16 equals negative 8 a sub 1 plus 0, because that goes away. That means a sub 1 will equal 2. Now, if you go back in your notes a little bit and actually look at example 2, we'll see that a sub 1 will equal, or a sub 2 will equal 3, and b will equal 2. A little bit differently, we did it on here, but you get the same result. You get 2 and 3 in your answer. Now, when we do it for number 2, there is a little bit of a change, a little bit of a typo on my part. There should be an x in between here. So for part B, we'll have negative x squared. We're going to put 2 in for there, so negative 2 squared plus 2 times 2 plus 4 is equal to a sub 1 times 2 minus 2 squared plus a sub 2 times 2 times 2 minus 2 plus a sub 3 times 2. So to do this here, this will be negative 4 plus 4 plus 4, so these two will cancel out. We're left with 4. This goes to 0. That goes to 0. So we're left with 2 a sub 3. That means a sub 3 will equal 2.
I'll be with you as soon as I'm done with the table.
Now, if we put 0 in and solve for a1, we'll get a lot of the same stuff. So negative 0 squared plus 2 times 0 plus 4 is equal to a1, 0 minus 2 squared plus a sub 2 times 0 minus 2 plus a sub 3 times 0. Well, as you can see, this goes away, that goes away at 0, so I'm left with 4. a1 times negative 2 squared, this will be 4 a1. That goes away and that goes away. That means a sub 1 will equal 1. Now in part C it says substitute any other value of x and use the values found for a1 and a3 to solve for a2. I'm going to let x equal 3 here. That means you get negative 3 squared plus 2 times 3 plus 4 is equal to a1, which is 1, times 3 minus 2 squared, which is 1, plus a sub 2 times 3 minus 2 squared, plus a sub 3, which is 2, times 3. Now, nothing's really going to cancel out here, but we will have negative 9 plus 6 plus 4 is equal to 1 times 1 squared, which is 1. 3 minus 2 squared, or 3 minus 2 is 1 squared, would be 1 times 3 would be 3a2 plus 6. Now, doing a little more simplifying here, negative 9 plus 10 is 1 equals 7 plus 3a2. That means 3a2 will equal negative 6. a2 will equal negative 2. So there you have that. So if a1 is equal to 1, a2 is equal to negative 2, a3 is equal to 2. So that's what we have. a2 is actually negative 2. And if you go back to example 3, where this comes from, you'll see that our numbers are 1, negative 2, and 2 get the same thing. So again, there's many different ways to use partial fractions. This one exploration is an example of that.